Dear students, in the previous session, I have completed the problems on logarithmic differentiation, and I told you that in the next session I will be starting the new function, the same chapter of course. Now, the heading is implicit function. First let us know the meaning or the definition of implicit function. What type of function can be called as an implicit function? Now, so far the functions that we have considered were of like this. Say y is equal to x square plus sin x, or y is equal to cos x plus e to the power x, something like that. Now, I am considering another type of function, x square plus y square equal to xy. Sin of xy is equal to x square plus y, etc. Now, I have considered here two sets of functions. Let us see the difference between them. Here y is on one side and all the terms containing x, the independent variable, on the other side. That is, y is expressed clearly in terms of x. So, I can write here y is equal to fx, isn't it? Because y is, we use the word explicit, explicitly expressed or clearly expressed in terms of x. Look here, x square plus y square equal to xy. We are having y square, we are having x into y term. You cannot separate y from other terms and write y is equal to some function. Similarly, here it is sin of xy and y we are having. So, we cannot write them separately, like we have written here. So, such functions, these functions are called as explicit function. So, how do you define them? A function in which y is clearly expressed in terms of x, or we use the word, if y is explicitly expressed in terms of x, we call it as an explicit function. It is called as an explicit function. Now, here y is not clearly expressed or y is not explicitly expressed in terms of x, and such functions are called as implicit function. Okay, implicit means here generally I can write y equal to fx, whereas here it is written like this, f of xy comma c equal to 0, or sometimes you can write f of xy equal to c also. That means that the meaning here y is equal to fx means y is expressed in terms of x. Here both x and y are mixed up, that is the meaning of that one. So, generally an implicit function is expressed like this. Now, our problem is when so far you have come across, it may be inverse trigonometric function or logarithmic, exponential, whatever may be the type of function we had considered, we had only explicit function. Y was always written in terms of x. So, directly when you differentiate, we will be getting the value of dy by dx here. It may be a chain rule or product rule or quotient rule or whatever may be the rule we were applying. Now, here since the terms are mixed up, directly we can't get the value dy by dx. So, next problem is, how do you find the derivative of this one? Suppose I am having a function like this, x square plus xy equal to y square. Look here, in such function, that is in the case of an implicit function, to get the value of dy by dx, what we have to do is differentiate each term with respect to x. Differentiate each term with respect to x, applying the appropriate formula which is applicable to that one. Here x square becomes 2x, here xy, x into y, into means you have to apply the product rule. But remember, always we are differentiating with respect to x only. So, here you apply the product rule, x square is a single term, you can write 2x, x into dy by dx plus y into 1, product rule. Come to the right hand side, y square. So, you have to apply the chain rule here. Y square means first you write 2y and y has to be differentiated with respect to x, which becomes dy by dx. So, here also 1 dy by dx, here also 1 dy by dx. So, collect all the terms containing dy by dx as a factor, take them to the left hand side. shift the remaining terms to the right hand side, then grouping them, taking out the common factor dy by dx, rearranging the terms, we get the dy by dx, that is the derivative of that particular function with respect to x. So, if it is an explicit function, directly we get dy by dx. There will be only one dy by dx term, because always y is expressed in terms of x. Right hand side, all the terms will be present on the right hand side, which will be differentiating with respect to x. So, left hand side it is only y, so we will be getting dy by dx. In implicit function, sometimes after differentiation, we may get one term containing dy by dx or two terms or three terms, depending upon in how many places that the variable y is present. So, this is the procedure we adopt to get the derivative of the function. So, an implicit function means if a function is not clearly expressed in terms of x, we call it as an implicit function. Now, to differentiate an implicit function, what we have to do? First, differentiate each and every term with respect to x. Then, collect all the terms containing dy by dx as a factor. Then, take out dy by dx as the common factor, then rearrange the remaining terms, which gives you the value of dy by dx. So, this is the procedure. I am not teaching you any new rule or new formula. Whatever formula you have learnt, it is a chain rule, product rule, quotient rule, and basic functions only we will be having. Even if it is a composite function, you have to apply the chain rule. So, no new formula will be taught now. Whatever already you know, whatever rules already you know, we apply them to the particular term here, depending. Suppose it is a quotient, apply the quotient rule. If it is a product, you apply the product rule. If it is a composite function, you apply the chain rule, like that. Whatever rules you have already learned, we apply it to each and every term depending upon how the term has been given to you. Then collect all the terms containing dy by dx and finally arrive at the result. Okay. So, this is the procedure we adopt. Now, we start working out the, nobody asked the question what do you mean by a implicit function, but you should know the definition of that one. That is why I taught you the definition. Now, let us find so now the question would be as usual, find dy by dx. Usually they ask you like that, find dy by dx of the following functions. One by one I am considering. First problem is y plus sin y. Y plus sin y is equal to cos x. The question is find dy by dx. The common instruction to all the problems. So, y plus sin y is equal to cos x. Look here, this is what I told you. So, you cannot write y is equal to something because sin of y we are having. So, two terms are containing y term, isn't it? The variable y. Now, write differentiate with respect to x. That means each and every term has to be differentiated. First, y becomes dy by dx because it is a simple function. Look here, sin y we are having. Now, it is a composite function. Sin x means simple, sin y means composite. So, sin y on differentiation becomes cos y because you know that sin of anything would be cos of the same thing. Now, y has to be differentiated, so which becomes dy by dx. Right hand side cos x, it is a function of x, so it becomes minus sin x. Now, both the terms are containing dy by dx. Now, take out the common factor dy by dx. What is remaining? After taking out, 1 is remaining plus cos y, that is equal to minus sin x. Now, we want the value of dy by dx. Therefore, you write here dy by dx is equal to minus sin x divided by 1 plus cos y. minus sin x divided by 1 plus cos y. Now, this is the derivative of the given function. So, this is how we have to write. See, in this problem we had two terms containing y. Otherwise, if they suppose there is only one term, then directly we get the value of dy by dx. Now, let me move on to the next problem. Here it is comparatively simpler. 2x plus 3y is equal to sin x. Here you observe, of course, it can be expressed in the form of an explicit function also. For example, you take 2x to the right hand side, it becomes sin x minus 2x and divide by 3, that becomes y is equal to some function. So, it comes to the form of an explicit function here. So, here also directly we differentiate with respect to x, differentiate with respect to x. So, 2 into the derivative of x is 1 as you know, 3 into y we are having dy by dx and the right hand side sin x becomes cos x. Now, in this problem there is only one term containing dy by dx. Keep it on the left hand side, shift 2 to the right hand side, that is 3 into dy by dx would be equal to cos x and 2 minus 2. Since we want dy by dx, right, dy by dx would be equal to cos x minus 2 divided by 3. So, this is the derivative of the given function. Now, we move on to the next problem. Here in the next problem, it is 3x plus 4y is equal to sin y. See, again in this problem, we are having two terms containing y, isn't it? So, automatically we will be getting two terms having dy by dx. So, you can have to take out dy by dx as a common factor. But let me differentiate first with respect to x. Differentiate with respect to x. Carefully you do that one. It is 3 into 1 plus 4 into y becomes dy by dx, that would be equal to sin y. Now it is a composite function. What is sin x? The derivative is cos x. So, sin y has the derivative cos y into for y it is dy by dx. Now, you observe that this is containing dy by dx, this is also containing. Let me take both of them to the same side. So, 4 into dy by dx. Now, shift it to the left hand side, cos y into dy by dx with a negative sign and 3 becomes minus 3 here. Therefore, when you take out the common factor dy by dx, take out the common factor dy by dx into what is remaining 4 minus cos y, that would be equal to minus 3. Finally, we get it as dy by dx equal to minus 3 divided by 4 minus cos of y. So, this is the derivative of the function. So, each term there will be slight difference from one problem to another problem. So, depending upon how the function has been defined, we differentiate them and get the derivative of the function. Now, another problem, y square is equal to 4ax. I hope you are familiar with this curve. In first year PUC, you have studied about the conic sections, and this is the equation of a parabola. Either it can be given as x square equal to 4ay or y square equal to 4ax. Here I have given you y square equal to 4ax. Of course, y is in only one position, only one term is containing y square, still it is considered as an implicit function, because when you write y here, it is square plus or minus root of 4x. So, there will be two functions. So, we take it as it is, y square equal to 4ax. Now, differentiate with respect to x, Now, y, if you write y, it is a simple function. Y square means it becomes 2y, but y has to be differentiated with respect to x. It is dy by dx. Right hand side, 4 and a, they are constants. So, we have to keep them as they are, and the derivative of x is 1. That is, shifting that 2y to the right hand side, we have 4a divided by 2y. You can do the cancellation, 2 2s are 4. Finally, we have that it is 2a by y. That is the derivative of this particular function with respect to x is 2a by y. Now, I am giving you another function which you are already familiar, that is x square plus y square equal to a square. Now, this is the equation of a circle having origin as the center. Again, all these curves, no, the parabola, the ellipse, the circle, the hyperbola, all of them in conic section in first year PUC you have studied. So, the same thing, same functions can be considered to find the derivative of y with respect to x. Now, here also you differentiate y with respect to x. Differentiate with respect to x. See, in this problem also, in this function also, we are having one term containing y square. So, when you differentiate, x square becomes 2x, y square becomes 2y, but for y it is dy by dx. Right hand side, look at the right hand side, it is a square which is a constant, therefore it becomes 0. See, in the previous problem you observe we had 4a into x here, isn't it? That is why I kept it as it is, 4a into x. See, the constant was multiplied by a variable, a function, therefore the constant was kept as it was, and then we differentiated that one. Whereas here a square is a constant term only, we do not have any functional variable with that one. So, automatically the derivative becomes 0. So, shift this term to the right hand side. 2y into dy by dx would be equal to minus 2x. Therefore, I want dy by dx here, it is minus 2x divided by 2y. You can cancel that 2 there, hence it is minus x by y. So, this is the equation of the derivative, so this is the value of the derivative. Now, suppose I had here x square minus y square equal to a square. Even that is also we call it rectangular hyperbola, which of course you have not studied. Suppose I had given you x square minus y square, then the same term would be present. Instead of minus x by y, you would have plus x by y. That is the difference here. Now, let me consider another curve, the equation of another curve which you are familiar. X square by a square plus y square by b square is equal to 1. I hope remember this one. It is the equation of an ellipse. Again, it is a conic section, equation of an ellipse. In this one, look here, x square by a square, y square by b square we are having. Do not apply the quotient rule here, because it is looking like it is a quotient only. But when do you apply the quotient rule? When both the numerator and denominator are containing the functions of x. Understand? Like we are having x by x plus 1. You have to apply the quotient rule, because it is also containing x, this is also containing x. Suppose I am having x square by 5, you should not apply the quotient rule because it is a constant here. So, you can write it as 1 by 5 of x square. Keeping 1 by 5 the constant as it is, only x square has to be differentiated. Or else if you have like this, suppose I am having 1 by x square. Here the numerator is a constant, denominator is containing a function. In this case, we write the derivative applying the formula which I had mentioned in one of the earlier sessions. 1 by x to the power n has the derivative minus n over x to the power n plus 1. So, I can write it as minus 2 over x to the power 3, writing this number with a negative sign and increasing the index by 1. So, here we need not apply any quotient rule here. Either the numerator or the denominator is containing the constant. The quotient rule is applicable when both numerator, denominator are containing the functions of x. Here a square and b square, both of them are constant. Therefore, you just keep 1 by a square as it is when you differentiate. So, x square becomes 2x, that is over, because always we differentiate with respect to x. Next, 1 by b square, write as it is, into y square becomes 2y. Okay, y square becomes 2y, and y you have to differentiate with respect to x. So, that becomes dy by dx. Right hand side 1 as you know is a constant, so it becomes 0. See here these are also constants because they are given with the function, they have remained as they are. Only the constant term, the single constant term we had, it became 0. That is 2x by a square plus 2y by b square into dy by dx will be equal to 0. Now look here, since we want the value of dy by dx, 2y by b square into dy by dx, shift this term to the right hand side, it becomes minus 2x over a square. Now since we want the value of dy by dx, whatever function is with the dy by dx, shift it to the right hand side, that is dy by dx would be equal to, here already we had minus 2x by a square, we have shifted that earlier. Now this has to go to the right hand side. See here it is 2y by b square, sort of cross multiplication, b square goes to the numerator, 2y comes to the denominator. So I can write it as b square divided by 2y. Now 2 and 2 only can be cancelled. Finally, I can write it as minus b square x over a square y. So, this is the derivative of the given function, which was the equation of an ellipse, Now, again, this was the equation of the ellipse you had learnt, isn't it? Suppose I had given you here, instead of plus, suppose I had given you minus, which is the equation of the hyperbola. Okay, the same procedure continues. Wherever plus sign is there, I will replace it by the minus sign. So this is also minus, that is also minus. Here this would be both, that negative sign get cancelled, numerically it would be same term we will be having. Instead of minus, the answer would be plus b square x over a square y. So this is how the function has to be differentiated. So whenever we have an implicit function, directly you can't get the value of dy by dx. So differentiate each and every term with respect to x. If there is only one term containing dy by dx, it is easier. If more than one term will be having dy by dx as a factor, group them correctly and take out the common factor, rearrange the remaining terms. Now let me consider another problem. Ax plus by square, that would be equal to cos y. Now, again in this problem also, there are two terms containing y as a factor. So, we have to differentiate each term with respect to x. differentiate with respect to x. With respect to x. Now, first one a, the derivative of x is 1, b, keep it as it is, y square becomes 2y as you know, but y has to be differentiated, it is dy by dx, that is equal to cos y. What's the derivative of cos x? It is minus sin x. Therefore, the derivative of cos y would be minus sin y, but y has to be differentiated with respect to x. Therefore, it is dy by dx. You observe, two terms are containing dy by dx because in the function, two terms were containing y as a part of the function. Now, shift this term to the left hand side, this plus a to the right hand side. When you shift them, it is 2by into dy by dx. This minus will become plus. It is sin y into dy by dx. Okay. Now, this plus a into 1, when we take it to the right hand side, it becomes minus a. Now, take the common factor on the left hand side. What is the common factor? Dy by dx. What is remaining? 2by plus sin y. 2by plus sin y. Of course, the right hand side is minus a. Right hand side is minus a. Therefore, since we want the value of dy by dx, take it to the denominator. Minus a divided by 2by plus sin y. Hence, this becomes the derivative of the function. So, each term, slight difference would be there in the expression of the function. So, depending upon how the terms are given, how the functions are given, you apply the appropriate procedure. Now, take another problem. X square plus xy plus y square equal to 100, or it can be any constant. Some constant would be given on the right hand side. X square plus xy plus y square equal to 100. See, this problem, of course, in this also, two terms are having containing the term y here. Here x into y, here y square. But you observe here, in the earlier problems, what we did till now, we had all individual terms, sin of y, cos of y, like this. In this one, we are having a product, that is x into y we are having. That means that for this particular term, you have to apply the product rule. I told you in the beginning when I defined implicit function, whatever rules you have learnt, the same rules should be applicable. See, y square, it is a composite function, we apply the chain rule. X into y, it is a product, so we apply the product rule. Okay. So, differentiate with respect to x. Differentiate with respect to x. Okay. Now, x square becomes 2x. No problem with that one. Here, since we are having positive sign, there is no need to write the brackets here. Suppose we had a minus sign here, we should have written inside the bracket, because when you apply the product rule, you know that there will be two terms we will be getting. First function into the derivative of the second plus second function into the derivative of the first. So, two terms would be there, both of them should be multiplied by the minus sign. Since it is a positive sign we are having, need not write the bracket. Now, apply the product rule. First function x into y has to be differentiated, that is dy by dx plus second function y into derivative of x is 1. If you want, you can put the bracket, but it is not necessary. So, this is over, this is over. Now, come to y square term. As you know, it is a composite function, y square becomes 2y. And what is the derivative of y? Again, dy by dx. And finally, 100. Again it is a constant term, so the derivative becomes 0. So there are two terms here, this one and this one, they are containing dy by dx as a factor, and these two they are free from that one. So those who are containing dy by dx, retain them on the left hand side and shift the other two terms to the right hand side. So how do you write that one? It is x into dy by dx plus 2y into dy by dx. That would be equal to, write the remaining terms on the right hand side. It is minus 2x minus y. Minus 2x minus y. Now take the common factor dy by dx. What is remaining here? X, and what is remaining? It is 2y. And here if you want, you can take out a common factor minus sign. It is minus of 2x plus y. Just to present the answer in a neat way, or a better way I can say. Therefore, what is dy by dx equal to? It is minus of 2x plus y divided by the coefficient. It is x plus 2y. Hence, this is the derivative of the function, or this is the value of dy by dx. So, whenever you come across an implicit function here, there may be any number of terms containing y as a factor, or there may be only one term also. Now differentiate each term. There may be any number of terms here. Differentiate each term with respect to x, and then if there are more than one term which contain dy by dx as a factor, group them. After grouping, you take out the common factor and arrange the terms properly. Those which do not contain dy by dx, shift them to the right hand side. Then grouping and dividing by the coefficient of dy by dx, we get the derivative. Now, suppose I am having a problem like this. See, x square plus y square equal to x square y square. Suppose I am having a problem like this. Then, see, here we are having sum of the two functions. Here it is a product of the two functions. Don't take the logarithm, because here you can take logarithm, whereas here it is the sum. Therefore, when you differentiate each term with respect to x, left hand side no problem, x square becomes 2x, y square becomes 2y, and y becomes dy by dx. And look at the right hand side. Right hand side, it is a product, isn't it? Apply the product rule. X square into y square will become 2y into dy by dx. Okay, plus second function, y square into derivative of x square is 2x. So these two are containing dy by dx. Shift it to the left hand side, shift this to the right hand side. That becomes 2y into dy by dx minus 2x square y into dy by dx would be equal to 2xy square minus 2x. Now, taking out the common factor and rearranging the terms, we will be getting this as the answer. 2xy square minus 2x whole thing divided by 2y minus 2x square y. Of course, you can rearrange them. You can take out 2x as common factor, we get y square minus 1. 2y can be taken out common factor, 1 minus x square. Now, why I have taken this particular problem is, sometimes such problems are asked in any competitive examination. When you differentiate, you may not see this as one of the options. Usually you will have the multiple choice questions. This may not be there as one of the choices. Now this problem, such problems need not be always square. It can be x cube plus y cube equal to x cube into y cube, or x plus y equal to x into y. All these one having the sum here, the product having the same indices. Here you can differentiate in a better way, in a simplified way. What we do is, first to divide by x square y square. Whatever you are having a product on the right hand side. Both the method, what I did was also correct. But here if you simplify the function, it may be easier for you to do the differentiation. When you divide by x square by x square y square, x square cancels and 1 by y square remains. Similarly, y square cancels and 1 by x square remains. Here it becomes 1. You observe, when it is a constant, as soon as you do the differentiation, that becomes 0. Now, I am applying the formula 1 by x to the power n. So, 1 by y square, you write it as minus 2 by y cube. Directly I am writing into dy by dx, and here it is minus 2 divided by x cube, that would be equal to 0. I am using the formula of the derivative 1 by x power n minus n over x to the power n plus 1. Write that index of the number x in the numerator with a negative sign, increase the index of the denominator by 1, which gives you, when it is a whole number, integer, it is easier for you to write the derivative directly. Otherwise, you take it to the numerator, apply the formula n into x to the power n minus 1. Now, rearranging the terms here, minus 2 by y cube into dy by dx would be equal to plus 2 by x cube. Even 2 can be cancelled, and shifting the term to the right hand side, we get the answer to be minus y cube by x cube. See, this looks entirely, but value wise both are correct. Even if you are differentiated as I did earlier, by rearranging or considering the original function, you can certainly get the result here. Both the, just to showing you, the same problem can be tackled in two different ways. The answers, they look different, but the value wise would be same. Both the methods are correct. So, you have to differentiate like this. So, when an implicit function is given, you differentiate each term with respect to x, and then collect the terms containing dy by dx as a factor and rearrange the terms, and finally you arrive at the result or the derivative of y with respect to x. In the coming sessions also, I will be working out, these are quite simple problems, I can say. Some complicated problems are there which I will be taking up in the coming sessions. Thank you.